Hi, I am Jawad from UJ NetLab. In the last video, we discussed about the DNS installation from scratch, and our DNS was running and ready. And now in this video, we are going to discuss about the configuration step by step. But before starting the configuration, we need to discuss some terminologies about what is our DNS architecture, about its servers, queries, and other stuff. So let's continue. So here you can see the DNS architecture. You can see there are three servers, the root servers, TLD servers, and at the bottom we have authoritative servers. What is happening when the DNS client, when for example the user type www.google.com or example.com in his browser, it goes this query to the ISP. ISP have some DNS resolver which do not have the entry for it. So what it's going to do, it is going to delegate its request to the root servers. Root servers are basically on the top of the hierarchy, you can see, which are total 13 in the world. It has the mapping of the other server, which are the TLD servers. So for example, I type google.com, so it will go to the root server, and then root servers will say, oh, it is .com or it is .org or it is .net. According to that one, it is .com, .net or .edu or anything, it will forward this request to the TLD server. It will not actually forward to the TLD server, but instead it will tell back, the request will come here, it will go to here, and it will say, hey man, to the ISP, say, here is the TLD server, it's located XY place, you need to go there. It will say, okay, I will go here. TLD server will say, okay, I am just the .com or I am .org, but if you want to go to the specific domain, which is Google, you need to contact to the authoritative server. Authoritative server are what? Which have the complete information of the DNS record. It has the actual IP mapping of with the name on its server. So it will tell, okay, you say, okay, I need to go here. Then finally, it will go to the authoritative server and it will give this IP to this DNS resolver and back to the client. And once this is established, and for example, if it goes again, it will, this DNS resolver have already in its cache, and thus it don't need to ask every time this information need to go to root server or TLD server or authoritative. It will directly give back to the client. So that is what happening for the cache, because this server is also acting as a cache. So this is what about the DNS architecture. Let's go to the next slide. Okay, this is already I explained to you what is a root server, or the entry point of the DNS hierarchy, guiding the resolver towards the TLD server. As I said, that this is the entry point, because the client is requesting to the ISP, because when you will go into the IP setting, you will see that the ISP in your home network, the DNS IP is automatically set. So it will go to that resolver IP first, and then this will forward, say, hey man, I do not have the full information. If you are .com, then go to this specific TLD server, and this will basically narrow down the search to the domain level, and then directing queries towards the server which is responsible for the specific domain. As I said, that who is responsible for the specific domain? Authoritative server will specific. So the authoritative servers hold the actual DNS records for the domain and subdomains. Domains, for example, UJNetLab, it could be mail.ujnetlab, it could be webserver.ujnetlab, it could be sdwan. Anything. It is subdomains. It is the final piece of information need to resolve the domain name to an IP address, because here basically we are knowing the IP and we are giving back to this one, and it is going to the client, because the machine talk in the IP world, but we human don't cannot remember all the IPs, so we need to put some the page name. So that's why we need the DNS for the name to IP resolution and back from IP to name resolution. Okay. DNS query types. First of all, we see authoritative query. What is authoritative query? Let's see. This is a Usenet Lab, which is our own server. And this VM client is going to request this ESXi Usenet Lab. I have the full visibility of this IP, and I have the mapping of um, this ESXi host, which is in the Usenet Lab in this server. So I do not need to go over there, because I am the one who is responsible and I have the IP of that server. So I will just reply to that one. This is called the authoritative query. This type query is resolved by the authoritative DNS server, has a definite record and for the requested server. The answer from the authoritative server is considered authoritative because it comes directly from the source of data, not from the cache or the third party. Meaning to say, it's not coming from the other DNS servers. Okay, this is what is authoritative. Now let's go to the next query. Now use type, for example, the user type twitter.com, and this client is have the DNS setting of this Usenet Lab. All right. In my DNS setting, this is the Usenet Lab server. It will go here and it will say, oh man, I'm not the authoritative person. Somebody else is. I'm not having this IP. I don't know. I know about Usenet Lab. It will contact them. It will act as a resolver and it will say, okay, I will find it out for you. Then again, this process will start. It will go back to it will go to the root server. Root server will go to the TLD server. And finally, it will go to the authoritative server, which has the actual IP to name binding, and it will give. But this is called the non-authoritative query because this server is not responsible. That's why we call it that's why we call it non-authoritative. No special configuration is specially needed on your part to enable the basic DNS caching if you are a standard DNS server software like bind built in future. Okay, we will see. As already discussed, that once it is reply from the public DNS, he has the cache information. So next time if the query come again to this Usenet Lab DNS server, it don't need to contact again and again to this public DNS because it's already in the cache, so it will go again back to this one. So that's what it's basically trying to mention here. Okay, so it's basically that hold the temporary copy of the DNS record in the cache, but they are not the authoritative server for this domain because I'm not responsible for Twitter. I'm responsible for this one. Hope it's clear. Now we have to see recursion, recursive, and iterative query. Recursion and iterative queries are basically the part of the same process. They are when a DNS resolver used to find the answer to a domain name query. They are related, but they are distinct. How they are related? First of all, we need to know what is a recursive query. Recursive query is the client. You are the client. You will say, hey man, I want to know twitter.com because I have the DNS setting here. I have the DNS setting of yours. So you get me an answer. I don't know. You have to do job. You will say, okay, I will try to find out for this one. So what it will do, that's why it's called recursive query. You see, to the resolver asking for the complete answer and wait. So he don't care. He just type user and then this server, this Usenet server has to be a delegator and then it will delegate to some other party to the non-authoritative server, which can be root server to again to the TLS server and then TLS server to finally to the authoritative server and then we'll give the reply back. So it is its job. So what is happening? This all happening going to this server to the root. This process is basically recursion. Recursion in DNS refers to the process of DNS server uses to resolve the query on behalf of the client by making a series of requests. Because we are doing series, we are asking root server, we are asking again and again to different, and it is iterative in nature, because every time it will say, okay, go to the uh, this server, then it will go to say to the another server. So this is iterative, it is incrementing every time. So that's why it is called iterative queries. These are the terminology, so it need to be clear what is the recursive, what is recursion process, iterative queries, so you know what's happening in the DNS world. Now we have the forwarder. Forwarder are what are doing. It is good. It's optional. It is not necessary that you have to do it. It is help. What's if let's go here. This is for the resolver, right? If you don't have this information of twitter.com, it will go to the, as I told you, it will go to the root server, and then root server will ask to go here, man, and then it will ask go to the authoritative server. But what if in the resolver I define that, oh man, don't go to here, don't go to here, go to this DNS server. Then it will directly go to that server, and it will where it was, yeah. Then it will give that's what it is written here also. Instead of performing the recursion process itself, it is not doing. It's not delegating its request to another server. Querying root or TLD, it should send the queries. It cannot resolve locally directly to the forwarder DNS server. Like as I told you, there are many public DNS server like Google, Cloudflare, which are IPs 1111, and many other servers are available. So it will forward to that one instead of making a recursion process, which we discussed. What will happen without the forward? Nothing is going to happen. It doesn't mean that it will fail to resolve the resolution, but actually it has to do more job. It has to make fulfill the client request. So if the recursion is enabled, it will start with the root server and then follow the domain hierarchy until it find the authoritative answer. So as I said, it's optional. Now next, go to the, if you disable the recursion, then what is happening? If the client say, hey man, I want to do go to the twitter.com, I will go back to this diagram. If recursion is disabled here, so what will happen is not going to ask to the external world. It will say, sorry man, I'm not going to do your job. I don't know the answer. So why will you do that? Because maybe I want to make my domain more secure. As you can see, also it reduces the loads on your server. And also, but what we can do, we can the disabling the recursion can be a security measure to prevent your server from being used in the DNS application attacks. What are those? Basically, these are also type of DDoS type of attacks there are. So with this help, you are just limiting your client to use your server only, and it will not forward any request to further. Even if you specified forwarder, as we mentioned before, if you mention forwarder, but the recursion is disabled, those forwarder settings will be ignored. I will discuss what are those settings, and we will see in the configuration file what are the these all recursion settings and forwarder settings. We'll discuss, don't worry about it. And then we have forward and reverse zone file. What is forward zone file? As you know, we need to translate the domain name into the IP. For that, we define the forward zone. It contains the DNS records that maps the human readable hostname to their corresponding IP addresses. For example, if we have UGNet Lab, its IP is 192.168.4.105. Then we have reverse zone. Those are optional actually. It's not needed that we need to map back IP address back to the domain name. But even if you want to do it reverse zone, then how it is achieved? It is achieved with the help of the pointer. For example, in the reverse zone file, we will make a PTR record which will map to the IP address back to the UJNet lab. Why we are doing this reverse zone? Because in some services it is good to verify the identity that the connecting device is really a way back to check if the IP addresses match with the known domain or not. For example, if you are sending the email, so it will check that you are not a spammer, sorry, that it is coming from the correct source or not. So with this help, you can use the reverse zone file. Also, it can sometimes it is used for logging also and security purpose, as I said, that to check that it is a valid IP address or it's coming from the known domain, or it's just some else is trying to make a DNS request. Recursion and reverse zone. Sometimes recursion is confused with the reverse zone. Recursion is different thing and reverse zone is a separate thing. Recursion is a method, as I said to you, or a process of resolution while the reverse zone are a specific type of zone file which is used for mapping IP address back to the domain name. The recursion is unrelated to whether the query is involved on forward or reverse zone. Recursion can also be used to resolve the names in both forward and reverse lookup scenarios. All right, and also recursion basically helps us the resolution process for the client, as the DNS resolver handles all kind of work to find the authoritative answer. It's a key function that allows the resolvers to serve client with the required IP address for the domain names. The reverse zones, on the other hand, are important for tasks like logging, authentication, or simply identifying where the traffic is coming from, which I already discussed. Okay, now let's start us the UJNet lab configuration. We have to go here on this and adjust the listen directive. What listen directive will do, I can mention on which port it has to listen. Let's go here. Okay, vi/etc name.cnof. Here you see it's listening to the 127. I will say no man, also listen to my 192.168.4.105. This is my DNS server IP. Okay, and now I will say what is saying option listen, adjust the query. Who can ask for the query? Maybe there are so many subnets, but maybe I want to limit that. Okay, these are the subnets who can query it. So I will say where is allow query, you will find localhost. No man, not only localhost, but also, sorry, I forgot the semicolon, otherwise it will give the error. Now here localhost 192.168.4.0/22. And then maybe I can add one more subnet, which I am going to use later on. Just this is an example, okay? Here is the allow query. Now what is the next step? Enable the recursion and security measures. I can go here. You see recursion is already enabled, but I can also make the allow recursion. I can limit the recursion. So the recursion can be only be initiated. The recursion is a process, as I told you before, that the client maybe ask, I need the answer. So to help the recursion process to occur, it will happen only for these subnets. If somebody else, for example, if I in the future I configure 210.20. Some IP, it will not happen. The recursion will not happen for those subnets. It will happen only on these subnets. So let's copy from here to easy my life. Just allow query. No, this is already done. This one. And enter. Okay. Now I can also configure forwarder. Here I go. Here's the this is the main file. Okay, name.cnf is the main file which is using for any kind of DNS configuration. We have already discussed what is forwarder is. Now what next? Now, what is DNS security? Is the security extension? It's providing the extra layer of security. And how? It is with the help of the seal that it's adding the signature to the DNS data. This way, when your computer looks up to the website address, it can check the seal to ensure that the proper response has not been tampered. So when the response comes, I typed twitter.com, maybe it is some middleman is tampering with my data and it is giving me wrong information and redirecting me to another one. So this is how it helps with the help of the digital signature. If the check fails, your computer knows the information might be compromised, so it will not go. If your DNS are running a DNS server, especially of a recursive one, that server client requests for the domains beyond your own. Enabling DNS security feature validation helps ensure that the responses you are relying on and providing to clients are authentic and haven't been tampered with. How you can do this with this one? You can put yes, by default it is enabled. Sorry, here by default, but I am going to make it no because I am testing. Actually, I face a issue. Uh, it was due to maybe other reason, but currently I'm going to just disable it. But you can enable it as you like and you can do your testing. Now creating a zone file, as I told you, it's contain the IP and name data and back. What is the structure of the zone file? We have three main thing we need to see. We have start of authority SO, which is acting as a title page. It contains a lot of information like the primary name server, the email of the domain administrator, and various timers related settings. Then we have S, which is the name server. List the server that you can translate names within the zones. Then you have address, which is directly maps a host name to the IP version 4 addresses. That's why it is called the authoritative server. Pointers, as we told before, it is used for the in the reverse zone files to map the IP addresses back to the host name. Okay, so no, sorry. Okay, we'll create now the zone file. Where it is, I will define the first the zone. Okay, I need to define also the zone here. But I forgot. This is the directory. So what I will do, I will change the directory to this dot. I can change also here. By default, when the DNS process started, it will see the zone file here. But I can modify here and I will can put here etc zone and then it will modify. But I'm not going to do that. I'm just what I'm going to do. I'm going to a dot slash. It's also not needed actually, but I am just using. What I mean is to dot slash is not needed. By default, it will already see this directly. So the zone name and the file name. I have not defined yet the file name. I'm just including. This you need to keep in mind. I am going to define outside this one. This is the forward zone and this is the reverse zone. I just define the definition. These are just the definition. And I will save it. Get etc, just verify. Okay, is there? Good, it's all there. Forward is there, recursion is enabled. Directory is this one, listening to the port and allow query. All seems to be all good. Now I need to also create the file. I just define the mapping. Okay, this is the mapping, but I need to also give the file name, right? So I will just copy, I will, as I told you, SOA and the DNS name. These are the some of the timer setting. That's it. UGNetLab is my server. DNS is the host. Here I define the name server in NS name server. And this is the name and records. I just give the extra IP. You don't need it, but in my case, I will just use this one, copy. All right. And I will go CD. What is the name? File name should be this. I will create file name this. VI is created blank. Let's copy this one and insert and save WQ. Now I'm going to create the reverse file. What is the name? The name is this. You see, it's contain the reverse. It is optional as I told you, but I am doing it just to show you. Okay, these are my two VM machine, DNS and ESXi. All right, I can add further later on. All right, those two files are created, and then I need to I'm just verifying there's no mistake. Okay, we already discussed the start of authority. We did know this one, and we need to define the ownership name. Ownership, because if you see the current ownership, what is this? The ownership is root, but the DNS daemon is running on the named profile. So I need to change it. Named, and what is this? Why it give error? Oh, sorry. And the other reverse one? Now you can see it is now all to this one. It's changed. Now this is all done. I need to now restart the service. CTL status named. It's already running in because we already done it in the last video, but I need to restart because but before actually restarting, we can also check the syntax. So I will not going to restart it now. What I'm going to check the syntax, name dash check zone. Here it is the command. Okay. It is going to check all the syntax. There is no mistake in the file. This is okay. Check zone. I am going to remove this one because it's not needed. It's also okay. So basically this check to forward zone and check the reverse zone. What if there is a mistake in the our old file which was named.cnof file? So for that I will just type this one, this command, name checkconf. It will check the named main file where we are defining about all the queries. So it seems to be all okay. I will also restart name service. There is no error, but let's re-verify. It's running. Great. So until now what we have to do, we have to do the checking of that we can really do it or not. We can do with the ns lookup, dig, and ping. So let's modify the IP, put the DNS in our client. Okay, now I'm going to change the, I'm going to put the IP easy. Opt-in, I will not change this one. I will just give my DNS server, which is on the same LAN. What was IP 105? Okay, okay, okay. And now I'm going to go on the CMD, ping ujnetlab.com. What happened? Sorry. Yeah, your dns.ujnetlab.com. See, now it's replying. NS lookup. Both do the same function, NS lookup and dig, but dig is more latest, uh, which has more visibility. You see, it's giving the server name and all. And also, I can check the other one, other host, which is my ESXi, esxi.ujnetlab.com. It's also giving me. Let's ping it. It's done. But what happens if I just ping the host? It's also pinging. Usually don't ping. What you need to do extra, because I have already done it, that's why it do not show it, but I will show you why it's showing. You need to add the suffix here. If I remove the suffix, now if I go back, I will not be able to ping the DNS. Ping request cannot find the host DNS. So that's why we need to add the suffix in our Wi-Fi setting. So now our DNS configuration has been completed. So we learned all those steps. Let's recap. We discussed the architecture. we discussed the servers, which are root servers. We have 13 total in all over the world. We have TLD servers, we have authoritative servers, which have the mapping from the name to the IP and back. And we discussed then the type of DNS queries, authoritative queries, non-authoritative queries. Then we have recursive and iterative queries. We discuss what is the recursion process. We discuss DNS with and without forwarder because it's optional. Then we discuss also the recursion and forward configuration. And we see the impact of what will happen when we disable the recursion. And we check how we can define the forward and reverse zone, and what is the difference between the recursion and reverse zone. Actually totally two different things. And then finally we define all the configuration in the named.cnof file, and two files separately we defined, which was one for the forward zone and the optional one for the reverse zone. And then finally we verified from our laptop, which was acting as a client, to make up authoritative request to this UGNet lab, and it was able to resolve. Yeah, one thing we do not check, which is ping.www.google.com. You see, there is a reply. Why? Because the recursion is enabled. You can disable it also, so you don't have the load on this your own DNS server, and for the security reason. I hope you have enjoyed the video and you like the content. Please subscribe to the channel, and in the next video we are going to discuss about the vCenter installation. Thank you. Goodbye.